This is our lesson number 70 in Sapphire Kingdom Gemology English medium channel. Here is the best time to be careful with beryllium. I am starting this special topic. This is part 1. We have to be aware of beryllium. Here I use beryllium treated stone immersed inside the methylene iodide liquid and take a shot. We can see like this. These are the inclusions inside the beryllium treated stone we can find. Spring-like inclusions. We are discussing under this part 1 and part 2. Beware of this. This is very dangerous thing. Another inclusion inside the beryllium treated stone. Lesson number 70. Now we can discuss from here. What is beryllium treatment? Beryllium treatment is a form of lattice diffusion. Lattice diffusion treatment. Such treatment, previously known as surface diffusion or bulk diffusion, involves the superheating of pale, colorless, poorly colored, or even dark material in the presence of other elements. Under here, very dark blue sapphires can improve to light, vivid color. So be careful. Gem treatments have become ubiquitous in recent years everywhere in the world. So many stones are treated, heated, or fracture filled. Pearls are bleached. Jade and turquoise is stabilized. These are the treatments we are using. Titanium diffuse sapphire has been around for a while and in fact is rather easy to spot. Titanium diffuse. Very big amounts available in Bangkok and the worldwide. It penetrates only the very surface of the stone. And if you look at it under a microscope, it is easy to see color concentrations along facet edges only. It is a problem as it can easily be removed with repolishing. When we repolish, the titanium diffuse sapphires will lose the color because color is near the top side. Now, the main problem was that the gem treaters denied strongly that anything new had been introduced. When them asked, they denied. The GIA dedicated a huge amount of time to running their own experiments and concluded that these gems had been heated in the presence of beryllium. See, in the presence of beryllium heated stones. The treatment was a form of lattice diffusion. But unlike with titanium diffuse stones, the color penetrates a great deal further and sometimes right through the stone. This makes it much harder to detect because complete gemstone filled with the color beryllium, filled with beryllium ions. So the color established everywhere evenly. Here, the process introduces yellow, orange, and brown components into stones, which results in bright yellow and orange colors from pale corundum. With this treatment, beryllium treatment, pale corundum colors can exhibit the vivid colors. The alteration of pink sapphire to Padmaraja, the conversion of bluish ruby to a fine red, and it can also reduce dark stones in blue sapphires to make it a better blue. Dark blue stones, very dark stones can make it better blue with the beryllium treating. So it is the very, very dark blackish blues can't sell. So we can't get the color from those stones, but it is not good thing. These are the beryllium treated sapphires. The issue is that it taking poor or low quality material and by infusing another chemical and heat into just below the melting point of the stone is considered crossing a line. It goes beyond enhancement as it alters the chemical state of the stone and, to put it bluntly, attempts to make a silk purse out of a source ear. Labs that do not have the equipment will often state on their reports not LIBS, not LIBS tested. If any report consists of this, that is not tested for beryllium heat treatment. Be careful. It is extremely hard to detect this treatment and requires specialist gemological equipment for a definite diagnosis. The treatment apparatus are still available in Canada only. Very high price to check the beryllium test. The trouble is that the treatment is very hard to detect. It cannot be detected using any standard gemological treatments. And in fact, there are only a few gemological laboratories in the world that can detect the treatment, as it requires a particular kind of laser treatment in order to take samples of the materials and test it. It is LIBS, LIBS, meaning is L for laser, I for induced, B for breakdown, S for spectrometer. The shortened form is LIBS. The most important thing is this LAICP-MS. LAICP-MS means laser ablation inductivity coupled plasma mass spectrometer. This is the very, very important test. LAICP-MS and heavily high priced. LAICP-MS can detect how do you know? How do you know about the stone? Is it beryllium treated or no? First reason is price. Second reason is color. Third one is microscope inclusions. We are discussing it one by one. Price, the most obvious one. Pay attention to the standard advice. If it looks too good to be true, it probably is. Beryllium treated sapphires cost a great deal less than untreated stones. So be suspicious of any stones that seem a great deal cheaper than they should be. It is first thing. Cheaper price tell us something. Second thing, color. Beryllium treated results in very intense colors, intense orange and yellow sapphires is very rare in nature. So if you are seeing a lot of stones like this, it may be in indication that it is beryllium treated. So very fine color is there. It is extremely rare thing. So think twice when you see that. But if it is natural, it is rare and it ought therefore to be very expensive. Some reports have estimated that most of the yellow and orange sapphire on the market is now beryllium treated. Better to be safe than sorry. Remember, better to be safe than sorry. Third one, it is microscope inclusions. Example, hollow fractures with beryllium treatment. These inclusions will look destroyed. Crystal forms turned into irregular masses, often with a cracked appearance and gas bubble in the center. This has not been observed with standard heating, so it is a good indication that beryllium treatment has taken place. You also might see synthetic crystal overgrowth on the stone. Look at this. The fourth reason is rims or rins on the stone. Look at the photos. You will need a liquid called methylene iodide. Methylene iodide, you know already, we use it to check the RI reflectometer. We use that small bottle. But if you immerse a beryllium treated stone in this, we can see like this. You will often see a different colored rim. See the rim, orange color rim around the stone, and the center is another color. It may not always be obvious. So whilst if you do see it, you can be pretty sure that the stone has been beryllium treated. Its absence does not prove no beryllium. In this area, no beryllium. But the around rim, there's beryllium. So this is very good thing. We need methylene iodide liquid to immerse the stone. Here, circular, look at the circular, curved and white lines associated to former zones of silk. Before beryllium treated, it is a silk zone. But after the beryllium treatment, it's like this. Circular, curved and white lines associated to former zones of silk. Magnification 50 to 100x in the microscope, fiber optic illumination can see this. This inclusion have so far only been detected in beryllium treated blue sapphires. Inclusions in the heat treated blue sapphire is this. This is heat treated blue sapphire. What is remarkable is that this photo was shot more than 20 years ago. This is more than 20 years ago, long before the advent of beryllium diffusion. Before the advent of beryllium diffusion, this photo comes with the heat-treated stone. This suggests that such inclusions do not necessarily indicate beryllium, that is diffusion, but simply high temperature heat treatment can see. This is high temperature heat treatment inclusions, not a beryllium inclusions, because the beryllium inclusion before 20 years of the advent of beryllium diffusion, it took. Circular thin film inclusions in an untreated blue sapphire seen scattered throughout clouds in intact rutile silk, approximately 30x. This is not beryllium treated. Circular thin film inclusions here, circular thin film inclusions and untreated blue sapphire seen scattered throughout clouds of intact rutile silk. These are the rutile silk. So this is given us, it is not heated, it is not beryllium, it is natural. The same circular thin film inclusions more highly magnified, approximately 70x. It shows this is not glassy discoids. See the rutile silks. It is a natural inclusion. One, the first step is look for signs of long-term high temperature heat treatment. That means altered inclusions, unusual fluorescence, changes in the FTIR is the test. FTIR Fourier transform infrared spectroscope. We can find if with FTIR it is heated or no. Any gemstone that shows signs of major long-term high temperature heat treatment will require advanced testing. If we can see a long-term heat treatment, we require advanced testing with SIMS or LAICPMS, very advanced technology, or LIPS to determine if beryllium presence. There are FTIR for heat treatment. If it is more heated, SIMS, LAICPMS, or LIPS to determine if beryllium is present. These are the tests you should understand. Next thing is impact of beryllium diffusion on very dark blue sapphires, where titanium 4 plus is bigger, percentage is bigger than magnesium 2 plus. Magnesium, the smallest amount is magnesium, titanium is big, then the beryllium diffusion should produce the condition titanium magnesium plus beryllium. Then the smaller amount of magnesium ions joined with berylliums, but the amount is little bit lower than the titanium percentage, substantially reducing the blue color saturation. Then it reduced the blue color saturation and showed how over dark blue sapphires could be lightened to a more commercial blue. The beryllium ppm range. ppm means parts per million. ppma means part per million atoms. ppmw means parts per million in weight. These are the two units we are measuring with LAICP-MS system. The beryllium ppm range required for visible color alteration in blue sapphire is as little as between 0.5 and 1.5 ppm. Parts per million atoms, it should be 0.5 part or 1.5. It is natural. There were some of the sapphires that had not turned yellow, but nevertheless were diffused with beryllium. During the beryllium treatment processes used to create the yellow and Padmaraja colors that were the focus of treaters during that period. Now that you have learned that basics, in the next section, I will present the most important and beautiful things you need to know. Now that you have learned these basic facts, in the next part, I will present the most important and beautiful things that you should know. See you in Beryllium part 2. If you haven't subscribed yet, please press the subscribe button and also click the bell icon. Always follow the lesson number order, write a note and study well. We are meeting in next part 2.